This is the third video in a series of 3 looking at using the mole equations on the screen to solve problems. This question asks, what is the concentration of sodium hydroxide which is formed in this reaction? And if we take a bit of time to look at the question before we proceed with attempting to answer it, just quickly read through. We're given 0.23 grams of sodium and it reacts with 250 centimeters cubed of water to form an aqueous sodium hydroxide solution, and hydrogen gas is also produced. The hydrogen gas is a bit of a red herring in this question. We don't want to know about the hydrogen gas, although it could be part of the question. This question is basically saying, what is the concentration in mole per decimeter cubed of the sodium hydroxide which is formed? So to start off, what we have to do is consider the stoichiometry, and the way we do that is to look at, well, what are we given? We're given a volume of water, but we're given also an amount of sodium. So the first stage in this reaction is as follows. Using our general formula for moles, number of moles equals mass over molar mass, we need to find out the number of mole of sodium that's reacting. And actually they made it easy for us, because we've got 0.23 grams of sodium, so that's our mass of sodium, and our molar mass of sodium is straightforward 23 from the periodic table. So the number of moles is 0.23 divided by 23, which gives us 0.01 mole of sodium. So now we move on to the second stage. So whilst I said this is not important, I've put the calculation in anyway, and this is to calculate the volume of hydrogen that's formed. So looking at the formula which we've given above and thinking about the numbers again, we've got 2 sodiums reacting with 2 waters to make 2 sodium hydroxides and 1 hydrogen molecule. So we've got effectively 2 moles reacting with 2 moles to make 2 moles and to make 1 mole. And we've just worked out the number of moles of sodium above, which is here, which is 0.1 mole. So a ratio of 2 to 1, this is 0.01. So if we halve this, we get the number of moles of hydrogen gas, which is 0.005, because the ratio of 2 to 1 is the same as 0.01 to 0.05. So the moles of hydrogen is 0.05 mole produced, and we quite simply convert that to a volume, and in this case I'm using 24,000, so I'm going to give my answer in centimeters cubed. Volume equals number of moles times 24,000, which is 0.005 mole, times 24,000, which equals 120 centimeters cubed. So the volume of the hydrogen formed in this reaction from 0.23 grams of sodium is 120 centimeters cubed, which takes us on to the final section, which is to work out the concentration in mole per decimeter cubed of the sodium hydroxide. So here's our equation which we've looked at above. We've said that 2 moles of this produce 2 moles of this. We've established that in this experiment we have 0.01 mole of sodium, and because it's 2 to 2, therefore we must have 0.01 mole of sodium hydroxide. And the final stage of this calculation then is to consider, well, we've got 0.01 mole of sodium hydroxide, but it's in 250 centimeters cubed. So now we use our equation, concentration equals number of moles times 1000 divided by the volume in centimeters cubed. Remember, if we were talking about decimeters cubed, we would not use the 1000 here. We would just use concentration equals number of moles divided by the volume in decimeters cubed. But as in the question, we are given a volume in centimeters cubed, hence the need for the multiplication of 1000. So we know the number of moles of sodium hydroxide formed, which is 0.01. We multiply that by 1000 and we divide it by the volume it's in, which is 250 centimeters cubed, which gives us a final answer of 0.04. So the concentration in mole per decimeter cubed of the sodium hydroxide which is formed in this reaction is 0.04 mole per decimeter cubed. Thank you.